dive into the fascinating world of large language models, or LLMs. Specifically, we'll be exploring 3 key techniques used to tailor their incredible capabilities for specific needs: prompt engineering, fine-tuning, and retrieval augmented generation, often called RAG. Introduction. Our focus today is on understanding these different approaches: prompt engineering, fine-tuning, and retrieval augmented generation. We'll look at how they work, their pros and cons, and when you might choose one over the others. The goal is to equip you with the knowledge to better leverage LLMs for your own projects. This presentation will explore these 3 key methods for tailoring LLM behavior to specific tasks and knowledge domains, ultimately helping us build more effective AI solutions. The LLM landscape. As you know, large language models like GPT, Llama, and Claude are incredibly powerful. They come pre-trained on vast amounts of text and can perform a wide range of tasks. However, out of the box, they are generalists. To get the best performance for specific applications, we need to guide or adapt them. Today, we're focusing on 3 primary approaches to do just that. First, prompt engineering, which is all about crafting effective inputs to guide the LLM's output. Second, fine-tuning, where we further train a pre-trained model on a smaller domain-specific dataset to adapt its internal knowledge or style. And third, retrieval augmented generation, RAG, a technique that provides external, often up-to-date information to the LLM at the time it's generating a response. Let's explore each one in more detail. Prompt engineering. First up is prompt engineering. This is often the simplest and most accessible way to influence an LLM's output. At its core, prompt engineering is the art and science of designing effective prompts, the inputs we give to the model to elicit the desired responses. So how does it work? Essentially, you're directly telling the model what you want, how you want it, and providing any necessary context within the prompt itself. Common techniques include zero-shot prompting, where you give a direct instruction, few-shot prompting, where you provide a few examples of the desired input-output, and chain-of-thought prompting, which encourages the model to break down its reasoning step by step. You can also define roles for the LLM, specify output formats, or set constraints, all within the prompt. Now let's look at the pros. Prompt engineering is quick and easy to implement. There's no model retraining or extra infrastructure needed beyond interacting with the LLM. This also makes it very cost-effective. It's highly flexible, allowing for rapid iteration and experimentation. And importantly, it doesn't require any training data as it leverages the LLM's pre-existing knowledge. However, there are limitations. It's limited by the model's context window. You can only provide so much information in a single prompt. Crafting optimal prompts can be skill-dependent. It's not always straightforward. It's not suitable for instilling deep, new domain knowledge that the model wasn't trained on. And often, finding the perfect prompt may require significant iteration. So, when would you use prompt engineering? It's great for simple Q&A on general topics, tasks like summarization, translation, or text rephrasing. It's also useful for creative text generation, basic code generation, and generally for quick, ad hoc tasks where you need a fast result. Fine-tuning. Next, let's discuss fine-tuning. This technique takes us a step further in customizing an LLM. Fine-tuning is the process of taking a pre-trained LLM and further training it, but this time on a smaller, curated dataset that is specific to a particular task or domain. The key here is that this process actually adapts the model's internal weights or parameters. How does it work? You start by preparing a dataset of input-output pairs. For example, these could be domain-specific questions and their corresponding answers, or examples of a particular writing style you want the model to adopt. The model then learns to mimic the patterns and information present in this new data. The advantages of fine-tuning can be significant. It allows for deep domain adaptation, meaning the model can learn specific nuances, jargon, and the style of your target domain. This often leads to improved performance on specific tasks, potentially outperforming a general model by a large margin. It can also teach the model new behaviors by adapting its style, tone, or even its implicit knowledge base. And once fine-tuned, you might find that shorter prompts are needed because the model has internalized some of the desired behavior. However, fine-tuning also has its challenges. It's data intensive. You need a high quality, curated data set, which can range from hundreds to thousands of examples. The training process itself is computationally expensive, requiring significant GPU resources and time. There's also a risk of catastrophic forgetting, where the model might lose some of its general capabilities if the fine-tuning isn't done carefully. A crucial point is that the model's knowledge is still static. It's frozen at the time of fine-tuning and doesn't learn new facts afterwards without retraining. And finally, proper fine-tuning typically requires machine learning expertise. Fine-tuning is particularly useful for developing domain-specific chatbots, like those for medical, legal, or financial advice. It's great for specialized writing assistants, for instance, generating marketing copy in a very specific brand voice. It can also be used for code generation tailored to a proprietary framework or API, or for improving classification and sentiment analysis for niche topics. Retrieval augmented generation. Our third technique is retrieval augmented generation, or RAG. This is a clever way to make LLMs more knowledgeable and up-to-date without retraining them. RAG is a technique that enhances LLM responses by providing them with relevant information retrieved from an external knowledge base at inference time. That is, when the LLM is actually generating its response. Let's break down how it works. First, the user submits a query or asks a question. Second, this query is used for retrieval. It searches an external knowledge base. This could be a vector database of company documents, FAQs, product manuals, or even a live database. The system retrieves the most relevant chunks of text. Third, this retrieved text is used for augmentation. It's combined with the original user query to form an augmented prompt. Finally, this augmented prompt is fed to the LLM for generation. The LLM then generates an answer that is grounded in both the original query and the specific context provided by the retrieved information. RAG offers several powerful advantages. It gives LLMs access to up-to-date information because the knowledge base can be updated independently of the model. This, in turn, significantly reduces hallucinations, as the LLM's responses are grounded in factual, provided context. Responses can also be auditable and citable, as you can often trace back the information to its source in the knowledge base, which increases trust. Compared to constantly fine-tuning for new factual information, RAG is generally more cost-effective, and it allows for domain-specific responses without full retraining of the LLM itself. But RAG isn't without its complexities. The complexity of the retrieval system itself can be a hurdle. Setting up and maintaining an effective retriever, including embeddings, vector databases, and search algorithms, can be challenging. The retrieval step also adds latency to the response time. And crucially, the quality of the RAG system heavily depends on the retriever. If irrelevant or poor quality information is retrieved, the LLM's output will likely suffer. It's a classic garbage in, garbage out scenario. Also, while it provides external context, the LLM's context window limits still apply to how much retrieved information can be processed at once. RAG is ideal for use cases like question answering over private company documents or internal knowledge bases. It's excellent for customer support chatbots that need to provide answers from dynamic product manuals or FAQs. Research assistants that can summarize and answer questions from a large corpus of scientific papers also benefit greatly. And it can be used for personalized content recommendations based on user history and a catalog of available content. Side-by-side comparison. Now that we've looked at each technique individually, let's see how they stack up side by side. This table provides a quick overview. If we look at the primary goal, prompt engineering aims to guide existing model behavior. Fine-tuning adapts the model's internal knowledge or style, and RAG focuses on providing external current context. Consider data needs. Prompt engineering needs none for model training itself. Fine-tuning requires a high-quality curated dataset. RAG relies on a well-structured knowledge base. When it comes to up-to-date information, prompt engineering and fine-tuning are limited by their training data, which is static. RAG, however, excels here as it can access dynamic information from its knowledge base. Another key differentiator is reducing hallucinations. While good prompting and careful fine-tuning can help, RAG significantly reduces hallucinations by grounding the LLM in factual, provided context. It can also be auditable, allowing you to trace answers back to sources, which isn't directly possible with the other two methods. Pause, allow time to read table. When to use which a guideline. So with these three powerful techniques, how do you decide which one to use? The best choice really depends on your specific needs, available resources, and the nature of the problem you're trying to solve. A good rule of thumb is to always start with prompt engineering. It's excellent for simple tasks, general knowledge queries, or when you need to iterate quickly. If you have limited resources, be it time, data, or budget, prompt engineering is your go-to. It's also a great way to establish a baseline performance before considering more complex methods. You should consider fine-tuning when you need the LLM to consistently adopt a specific style, tone, or format. It's also valuable if you need to teach the model new skills or reasoning patterns that aren't well covered by its pre-training, especially for a niche domain. If the task relies on implicit knowledge or patterns that are hard to articulate fully in a prompt, and crucially, if you have a high-quality labeled dataset for the specific behavior you want to instill, then fine-tuning is a strong candidate. However, remember, fine-tuning is less ideal for managing constantly changing factual knowledge. Then, you should opt for RAG when your application requires access to large, dynamic, or proprietary knowledge bases. If accuracy and avoiding hallucinations based on up-to-date information are critical, RAG is often the best solution. It's also the way to go if you need to provide users with citations or sources for the LLM's answers, or if you want to query over specific documents, like asking the LLM to summarize Chapter 3 of this PDF. And very importantly, remember that these techniques are not mutually exclusive. Hybrid approaches are often the most powerful. You can absolutely use RAG with a fine-tuned model, and both will always benefit from good prompt engineering. Simplified decision flow. To help visualize this decision-making process, here's a simplified flowchart. Briefly walk through the flowchart, hitting the main decision points. You start by asking if you need to customize the LLM output. If it's a simple task or general knowledge, try prompt engineering first. If not, consider if you need access to dynamic, proprietary knowledge, or if you need verifiability. If yes, RAG is a strong contender. If those aren't the primary drivers, then ask if you need to teach the model a specific style, tone, or a new reasoning pattern, and if you have quality training data. If yes to both, then fine-tuning might be appropriate. Conclusion and key takeaways. So to wrap things up, let's recap the key takeaways. Prompt engineering is your foundational layer. It's always the best place to start. It's fast, cost-effective, and often surprisingly powerful. Fine-tuning is very effective for adapting an LLM's inherent style, behavior, or specialized skills, especially when you have good training data. It essentially internalizes new knowledge or behaviors into the model itself. RAG excels at providing LLMs with up-to-date, domain-specific, or proprietary factual information at query time. This enhances accuracy and reduces hallucinations by externalizing the knowledge source. The optimal strategy frequently involves a combination of these techniques. Understanding their individual strengths and weaknesses will empower you to build more powerful, reliable, and customized LLM applications. That brings us to the end of the formal presentation. Thank you all for your time and attention. I hope this overview of